Hey everyone, now it's time to look at the statistical model data visualization. So in the previous lecture we looked at what is statistical model, what it means, what are the statistical model available in our language. Now it's time to do the hands-on. So first plot we are going to look at is the correlation plot. So what do I mean by correlation plots? So if you remember in the previous correlation plot, it just help you to determine the pairwise relationship between each other. So we will have some data and we will try to predict some correlation plots. So before we jump on to the building correlation plot, we need to know what data set we are going to use. So we are going to use our mosaic data. In this we have house in Sarasota County, which provides us data on houses in Sarasota County, New York, USA. Basically, it provides price, lot size, age, land size, value, living area, all those values. What we are going to do is we are just going to create a plot in this. So if you are ready, what we are going to do is open our RStudio and code this out together. So now let us open our RStudio. And RStudio open, and it is asking me if you want to install new updates available. You do want to install, so I don't want to install, so I will say remind me later. And what I'm going to do is open a new file, and we know the shortcut, that is Ctrl+Shift+S, and creating a file stats, in which we will have all the statistical model code. And the first thing we need to do is we need to have the data set. So we are going to call data, sorry, in small data, and then from this we need to import a surrogate tree house. If I am correct, the spelling is SARA toga house, and then in this we need to import a package, that is mosaic data. And before we move on, we need to clear all our environment variables. Let us clear those and then let us enter it. Uh, it's not able to find it because there is a spelling mistake. This it should be mosaic data, and then enter. Sarasota house did not found, so it's houses, Sarasota houses. I checked online, so it's Sarasota houses. So it's saying promise. We know that if you once we click, we get the houses. So what we need to do is uh, we need to get all those data which are having only numerical values. We don't need heating fuel, sphere, and others, those data states values. So what we are going to do is, so once you have got the data, what we need to do is we need to select only that data that is numeric. So what we will do is we will use dplyr package. So data frame, in this we need to only select the package that is numeric. So dplyr, and from this we will called select if, and then from the data set we need to provide that is table, and then the condition. So houses and is numeric, only that value. So let us check. So once we run this, we will get all the data that is numeric. Now what we need to do is we need to calculate the correlation. So for this we will declare a variable r, and in this we create a variable correlation, and it's used to calculate the correlationship between each other values. So data frame that we need to use, and df, and use complete dot obs method. Basically it's some method that we need to use, and let us enter. So is required is passed. It's not a method, it's a sorry, it's not a function, it's a method. So we'll get all the value, and we have got all the value uh, correlationship between each other. So this value lies between 1 to 1. So price to price ratio is 1, and then so if you want to connect price to lot size we have 0.1 point of relationship, but we are not able to get any idea about this. So what we'll do is basically we will do is we will create a plot. So to create a plot, we will need to first basically round off this thing by 2 parameter, because it's very having lot of boolean value. So like we need a systematic, or like how many decimal we need, so we'll keep it to 2, and we will have still have the relevance of the data, and then we will use our plots, that is library ggplot and gg correlation plot that we need to use. Gg correlation plot, and then correlation plot, and then in this we provide the r parameter, and then we get all the values. So we could see that this part, if is the middle red part in the graph, you see is red, because these is uh, correlated with itself, so it makes sense that it have the price to be red. So living area have utmost effect on price, and then we could see that bathrooms also have utmost effect on price. We could see that living area and bathrooms have next most correlation, that living area should have more number of rooms and more bathrooms. That makes sense. Then we could also have see that price living area, then we could see next we could see bathrooms and living area, which is same, and here we could deduce the effect. We could see that age and lot size doesn't matter in most of the case, doesn't have too much relationship, and most of this when you age more, you have negative relationship with the bathroom. So like people don't need a bathroom, that what is making it sense. We could see bathroom and age, which is the same thing. As we could interpret a lot of things from this graph. So now you have got an idea how to plot correlation plot. Now it's time to look at the next plot. But before we move on to the next plot, what I want to do is, there are few things that we could add to this plot. What are the few things we could add is, we could provide some parameters. So R is one parameter, then HC order, uh, logical value if 2, using its, so to highest to lowest order, and most of the other graph would be removed. So HC order is, we will provide it to be true, and it will remove other repetition, like similarly we have for bathrooms and age. Here in this graph it will remove for the age and bathroom thing, and then in the type we could do it for lower, and then lab, basically add a correlation coefficient on the plot. So we need to add, if we want to see how much it's affected, we could add those by adding 2, and then we get this plot. We could find out that the highest correlated thing is room versus living area, which is about 0.73, and for price we could see it's also the living area are the most affecting thing. So living rooms price are the most factors that is contributed to the price that we could see, and bathroom as well. And next, age is very negatively correlated. The age you have, the less you pay for those. It makes sense. So we have got such a nice plot. Now our time is to work on the next plot, that is linear regression. And now let us see what is linear regression plot is. Hey everyone, now it's time to learn about the next data visualization model that we are going to use is linear regression model. So what is linear regression model? So we remember that we have some terms, y is equal to ax1 plus bx2 plus cx till xn, and so here this y is known as dependent variable, and here this is the explanatory variable that we know, and then the quantitative response, that is independent variable that we're trying to predict. So linear regression allow us to explore the relationship between quantitative response and a explanatory variable, while others are variables are constant. So in our previous data visualization in correlation plot, we saw that there was some relationship between the price and some living area. If we check again, if we look at the price, there was living area have um, one of the highest factor, then bedrooms, rooms have the major effect. So if you want to calculate the pricing ratio, that what will it affect, using linear model we could able to find out, okay, what are the, how much price is affecting the, these other parameters are affecting the price. So we will, what we'll do is we will create a linear regression model and fit into it. So with this, let's open your R Studio and let us code into this. Now what we'll do is we will basically code this out. So if you remember, what we'll do is we will clear our console, console. So control shift enter, clear, basically clear. So now it's time to do the code hands-on. So basically what we do is we will remove all the unnecessary variables that will not hinder us when we plot. So we remove the plot. Now what we'll do is we'll first basically get the data. So stats, we need to get the get a house data set. So we'll first get that house data set, Saratoga houses, and then we need to have a package that is mosaic data that we have. Let us see if that's correct. So generally the naming is odd, so we have some typo, but we have fixed it out, so we get the data. Now what we need to do is we need to create a linear model for the pricing. So what we'll do is we will create a houses linear model. In this we will create a linear model which will call using houses linear model. And if you press if you look at this, you are able to get, okay, what are the parameter it's required. So it's required formula, data subset, weight, action, method, QR. So you generally need to provide the data set that what you need to predict against, that is the dependent value. So this would be our price. From which data set we are going to include it is from Saratoga houses. Then we need to include the lot size. Then it's against, then we should have the independent value is lot size, age, land value, and we could include living area and bedrooms. Basically these are the most thing, rest I'm just adding just to see tell you that those value won't play any major roles. Bathrooms and waterfront, and then which value from which data we need to add is it's from Saratoga houses. So if I enter this out and save it, you get an idea, okay, what we are doing. So here we have got our large language model, and here you are able to get some coefficient dependency on those. So basically some have negative and all those things. Fitted value, basically this is how your model looks like. But what we are going to do is we are not able to understand those things. We are human beings, we need a data visualization plot. So how we will do it? So we need to import a library, that is our favorite library, that is ggplot, then visual regression to plot this out. So I will import those library, and then we could import ggplot2, then we could import our visual regression, and then we could say visual regression houses, LM, and living area, GG is equal to true. Now let us see. So here is the plot against the linear regression, and we could say that okay, it's following a straight line. What against the land value if we need to plot again? And we have seen that the price generally the living area size increase, the price increase, and that's a true case in real world scenario as well. So if we add bedrooms, so what do you think? What would bedrooms plot would look like? So it's generally decreasing. So if more bedrooms, there is slightly decrease in the price. So uh, okay, so for 2 BHK you have more price, but if you consider that's the true case scenario, that it's not always the case that the number of bedroom is there, the price also decrease in that fashion. It generally is lower than the double. So that's what it is trying to say through the graph. And if we look at the other things, so if we do with the age, what do you think? So it's also decreasing, price also decrease with the age as well. So a lot of old people won't want to buy the old house at the age. And you could see that there's some age that is noise data, that is no one is able to live around 150 to 200 years. That's impossible, and I'm pretty sure this data have a lot of noise here, so we could remove that as well. So uh, we should also handle those kind criteria as well. Now let us look at the other things. So let us say we have done with bathroom. What about what other data we have trained on? So let us say waterfront. So waterfront, and you could see this is linear, but other mostly it's better to use GLM on those, because it's a yes no condition. So if price waterfront have, so its price increase, if doesn't have, its price decrease, and you could see that thing here. But basically you got an idea. Okay, living area have most effect on the price, and if you able to look at this, you will be able to get an idea. Okay, through the graph you are able to get an okay, there is the alpha of this is the coefficient is positive. So the number of price living area increases, the prices also increases. So we have got an idea. If we let's check against the value for land value and see. So we haven't checked for the land value, and that was sure that if the land value increases, the price also increases. So that's a clear proportional thing. You will see that there is generally tend to increase over those. Now there is some challenges for you. So what if you need to add some labels to it? How you could add those labels? So to add the labels, we remember labs, and we could provide the title to it. So in smaller case, title, and then the string relationship between price and land value. So and you could also add the x axis values and y axis value, and let us see, we get the title to it. So we have checked a lot of linear regression model onto this. Now let us move on to the next model that we are going to use is GLM based on logistic regression. Now it's time to look at the next plot, that is logistic regression plots. So uh, in the previous lecture we looked at what is logistic regression model, basically a GLM model that we use, and where it is useful. Basically it is useful where we need to calculate binary response, that is yes or no. So logistic regression is basically can be used to explore the relationship between a binary response variable, that is or dependent variable, and an explanatory variable, that is or independent variable, while other values are held constant. Binary response variables have two levels, yes, no, live, die, pass, fail, Malgin, Bennigan. As with linear progression, we can use this visual regress package to visualize the relationship. So we are going to use visual reg package, visreg package to visualize the relationship. So basically I will open my RStudio again. What will I do is basically clear the code and clear all the environment variables so we don't have any um, mishappening. So that variable is already declared and we are trying to access it. So what will I do is, before we jump onto code, I want to show you the data set that we are going to use for visual review. So we are going to use data from 1985 current population survey. CPS is used to supplement census information between census year. It consists of a random samples person information of wages and other characteristics including sex, number of year of occupation, religion, or so basically what we'll do is basically plot okay at which year at which age that the person was married or not married. So it's a yes and no, and whether once you hear this type of question you need to know that you need to use regression logistic regression model, that is GLM models, that is generalized linear model. So let us see how we could use it. So what I will do is basically import the data set, that is CPS 85 if I'm correct, that is from data um, that is from data Mosaic data, and let us see if it's available or not. Not found. So we have a little bit of typo moves. So let me check if this dataset is available or not, else we have to install it. So we have got our data set. Basically there was some typo, CPS 85 package Mosaic data. Once we got this data, we get lot of observation in it, basically when it was married, race, sex, Hispanic or not, experience. So we are going to plot that at which age that the marriage was there, at which age the person have been married or not. So for this we are going to create a variable CPS let's say 85 algorithm, which will be what we are going to use is GLM model that we are going to use, and we are going to say married. If married, then what we are going to do is basically we're gonna add all the rest of the parameter that we need to compare from. So the gender, then the age, then uh, the race. We are going to see that at which race, then let's say sector most probably, and then we are going to plot it with against the or age thing, that at which age the this thing was done. So the family that we are going to use, the equation is binomial equation we are going to use, and then the data we know that we are going to use is basically CPS 85. So data and then CPS 85 data we are going to use, control shift enter. So binomial function is not defined, so let me, so we have a little typo, now it's working. So we have got a list of 30, let's see. So we have got some coefficient and we are generally not able to get those things and visualize it here properly. So for this we are going to use our visual reg plot, and to use visual reg plot we need to import ggplot first, and from this library is needed for to use our visual reg plot. So we'll call visreg plot, and then once we have imported our library we'll call a function visreg, and here you need got an idea okay what are the data we need, and if you press F1 you get the documentation. So okay, so what we need to do is basically give the fitting of the data that we need to provide, that is the fitting that we have done here we need to provide, and the rest of the data we need to provide, basically that is the GG, it needs to be the true against which feature we need to plot against, that we need to provide. So let us look at one by one. So the fitting that we need to provide it against is the CPS 85 algorithm. So that's the fitting that we need to train against, and then uh, the thing we need to plot against is the age, and the GG is, it should be true, and basically here you could find that the GG stands for, and if you find in topic, you get open the documentation as well, but if you um, press GG here, and if you the GG is condition is like if you need to have those data variable onto those or not, but it's a little odd that they don't have those documentation onto this. But if we put true with the values on the plot, and we could add the scale is based on the response, and if this needs to be in the string type, let us save, and here we get the values based on those, and we could see that basically the person is married around the range of 20 to 30 are marriage, and this is almost zero for the person who is at the range of 60. Now what we could do is we could try to see, okay, let's say what other factors we could have. Let's say salary, if we have, so we don't get the, okay, so we have a wage thing in this. So let us say if wage is the thing that affect or not. So let us add a parameter wage, and here let us see the wage thing if it's related or not. So the thing is wage also affects those. So if you have high wage, ultimately you have low chance. So here it's little bit odd. You could see that here you have 0.2, and basically it's explaining the thing. So it's a yes or no thing, and basically in binomial thing what it does is if it's greater than 0.5, then it's a US condition. If it's less than that, it's no condition. So how that's how the explaining things of GLM works. Now let us plot other plots, that is a survival plot we are going to plot, and see what how we could plot those data using plot the data using linear models. Set we are going to use, that is NCT CCDG lung cancer data, and we have in the first lecture of data visualization we have installed this data set. So here's the data set that we are going to use and plot this. So basically what we have done is I have already coded this out. Basically we have used a survival data set and survival minor basically to fit the data set, and we have used data lung for this. So what we are going to do is basically stop those. Let us look at the last plot that we talked about as research plot, sorry, survival plot. So basically what in so now let us talk about the last plot that we are going to look at is survival plot. So what is a survival plot? So in survival plot, there are a lot of times then when the dependent value, the independent value is the time to an event. So basically, for example, in healthcare, this is the time where patient suppose is before. Uh, in this case, if this could be the time of event in which the thing could be like survival probability based on the time. So this is how we are going to use a survival plot. Basically, we are going to use SFIT for survival plots, and we are going to look at the two data set that we are going to use. So basically, we are going to use NCCTG lung cancer data set, and basically it has the data set that includes data set of the lung capacity. So let me open in this tab, and then here is survival in patient with advanced lung cancer from North Central Cancer Treatment Group. Basically, you have the time, survival time in days, and the censoring status. Once status means one is censored, uh, two means that patient have died. So basically, we are going to use this probability to deploy our code. And let me open my RStudio, and here's the code that we have. I have already coded out. Basically, it's a very small code, so I will just explain. And this is very generic one. So basically, it's only uh, for survival data. We use Kaplan mere curve that we use basically. So here we have used those data lung data set, and we have used survival fit from the survival mere, and then serve from the survival. And then we are trying to do is time and status. Basically, if the patient is dead, we plot those, and through this only we are using the data set as lung, and then we use ggserve plot, and then we fit those data, and here we are able to get the survival probability. So if the time is less, the chances of survival is more. So basically, if you are able to detect at an early stage, your probability is higher than detecting at lower stages. So that's how this probability curve works. And now the R data visualization lectures have been completed, and with this we are in the next two lectures we are going to do some project works that will help you to add those projects onto your portfolio. With this, I will see you on to the next lecture. Thank you everyone.